Okay, so again, this is a presentation on the precipitate lab that we're doing. It's really also called ionic interactions because it's interaction between two ions or more that give you a precipitate or give you some aqueous substance. So we're gonna go really quickly. So you're going to add two solutions that will create a precipitate. First, let's examine what will happen physically. We're going to look at what happens at the atomic level. Why does this happen? You're going to use the following volumes. Let's just say we've got 20 mLs of substance AB and 30 mLs of substance CD. So I've got two beakers. One of them has 20, one of them has 30, and they're both different compounds, but they're both concentrated the same way at 1 ml, 1 ml. So again, visualize that you've got soluble ions in there, jittering and moving all over the place. They're not glued together. They are soluble. They are surrounded by water and they're moving all the time. And you got A, B, and C, D. And if we zoom in closely at both solutions, this is what you're seeing. You're seeing A, aqueous positive, and B, aqueous negative, just jittering all over the place, and D and C both also jittering all over the place. Now, again, this is happening because they are soluble substance. They separate once they go into water, but as soon as you evaporate the water, they recrystallize and they become AB or CD. But once they're in water, they're soluble. They just jitter, okay? So both compounds are soluble in these solutions. Now, mix both solutions and examine under the microscope, see what happens. Now we notice there's this precipitate forming on top that's floating, and some of them don't react because they're either positive ions, so they don't come to each other. Yes, Nico? Yeah. Okay, so Nico's asking about the diagram before, about the picture where you add two clear colorless liquid and they become yellow. You may get that one as an example. You're going to get actually six of them. And some of them will give you yellow, some will give you red, some will give you white, some will do nothing. Okay? Some of them will be floating on top, some will be sinking to the bottom. But the important thing to notice is that you got two clear liquids and suddenly you've got formation of a solid and change of color. So right away it's a chemical change, it's a formation of precipitate. Now, if we zoom in at the what's going on top, not yet, but this is what we're getting as our product. We're getting A and D coming with C and B. So what happened again is that expression that I shouldn't have used last time. You got molecular swingers. You got B and D exchanging spots to going to AD and CB. This is not new. This is pretty much straightforward. So this is before and this is after. Okay? Now, notice the after, some do bond to each other to form precipitates. Now, if you look on the left side, these guys are not together. If you look on the right side, the AD and the AD, they seem to be glued to each other. That's your precipitate. Because in water, they're not soluble. They cannot separate from each other. As soon as these guys encounter each other, they glue to each other, and basically it's a permanent relation. Whereas the other guys, C and B, it's not a permanent relation. These guys are promiscuous little bastards. But the other two guys, they're monogamous. They stuck to each other. It's a unity. There's love and happiness going on after. So this is your precipitate. That's in the square. And again, now we're in the beaker. So these guys float on top, and that's your precipitate. The other two, the B and C, they stay dissolved in water. Yeah. It's by nature, you'll see, okay, the question that we asked is why does this happen? You'll see in chemistry there's something called redox reactions, where certain things that when they bond in water, they're just not soluble. And others are soluble, okay? It's just the way it is that they're not soluble in water. And you'll see a bit more of that in chemistry if you take chemistry next year. So insoluble precipitate floats or precipitates. Get it? Insoluble floats or precipitates, okay? Get it? So precipitation basically means you're creating something. Soluble salt is dissolved in water. What is solubility exactly? Solubility is ions being surrounded by a matrix of water. The water molecules form matrices around each of those ions. So now the gray dots that you're seeing are what we call van der Waals forces. And you'll see more about that again next year. Basically, the hydrogen, which is the white atoms is being attracted to either negative C or being pushed away by positive B. So this is what happens at the under the microscope. This is actually happening, that each of those ions is being surrounded by a matrix of water. Are we clear on the diagram? Okay. Whereas with the precipitate, this doesn't happen. The precipitate is just on top, being pushed by the water. Yeah. Okay, I'm going to explain it. The B and C are soluble ions. What makes them soluble is that they get surrounded by water. So they can float easily in water as you want. Whereas the insoluble precipitate, they don't get surrounded by water, they just get pushed upward. Water is not interested in surrounding them, water is not attracted to them, they're just being pushed upward. Whereas here, the B and C are either attracted by oxygen or attracted by hydrogen. Now, oxygen is the negative thing that attracts the positive ion, and hydrogen is the positive part that attracts the negative ion. Yeah. Are they heavier? It depends what you're dealing with. Most of the time, it's either two metals, one being a metal, which probably is heavy, and the non-metal, which could be also heavier than oxygen. Right now, you got oxygen, hydrogen, and these guys could be anything. One of them has to be a metal, the other one has to be a non-metal. Yeah. Forces. Yeah. You mean no? The van der Waals forces. This is an advanced topic. This is not. You don't see that in Sec 4. Okay, that's more Sec 5. Sean, you had a question? Okay. Alright, so the soluble substance is dissolved in water thanks in part to forces of attraction and repulsion between the water molecules. Of course, if we had to do this as a lab that counts, unfortunately it doesn't count because it's just a practice formative. After you react these guys, you'd have to filter it, bake it, and weigh it to see if your stoichiometry math proves that whatever you predicted is correct. But unfortunately, we don't do that. So that's pretty much it for this presentation. It's a short presentation. It's just to give you guys a